All right, so here we are. We're down to Chapter 13, Attacking Users. There was going to be a guest speaker, but I'm not going to have a guest speaker on these Wednesdays. They're coming in on other days this week. So I've moved this chapter here, and I'll have last couple of classes. I'll announce the topic later. And so keep doing Web Security Academy. 20 points of it, which is 2 projects this week, next week, and the week after. All right. And so let's start looking at these techniques to attack other users. Yes, there, all right, there we go. Okay. So, request forgery. This is a real important topic. And first, so the idea here is, and we've already been done in some of the Web Security Academy projects we've already done, instead of stealing somebody else's password or stealing their token and adding it to your browser to imitate them, you just trick them into executing an unexpected action. So you put script on a page, and then when somebody views the page, the script causes their browser to make a request which they didn't intend. So this is called session hijacking, session riding, where I never need to steal the token, I never need to touch it. The victim views the page, and the altered page does something unexpected to them without me having to be directly involved in that at all. So I've got an example of it here. This is the simple case on-site request forgery. And so it goes like this. You have a message board where you put in type of thing like question, and then a name like Max, and a message like how to hack this. And when you go to that page, it prints your name here and your message there, and there's an image here. And if you view the source, you'll see what happened is the question turned into the file name of the image. And it literally took this name from me. So you can check that. If I put in something else, like question X, and submit it, notice how the picture is no longer visible. And if I view the page source, it really did change that to question X. So now this is a lot like the stuff we looked at before. I control something inside the image name, inside an image source tag. But I can certainly add script in there if I want to. And so let me get the, so here's the recommended attack. You put this in the type field, and what's going to go on is it's going to put this in an image field, and the image is going to load a PHP file, which will run the PHP file. When it tries to load it as an image, it has parameters, so it's going to create a new user with that name and that password and that role, and then the pound sign here will terminate it like a comment. So, or it'll be like a, I think like the fragment in the URL, so the rest of it will not be used. So let's run this, and see it pops up saying new user called. The result is new user created. And if you look at the page source, you'll see source is images / then this junk, and username. Okay, so anyway, that's the game here. It ran that script. And the pound here is one way to terminate it so it doesn't worry about the .ping and just runs this script with those requests. So simply viewing this page will send this request to a PHP script and do whatever it does, in this case, create a new user. All right, so that's on-site request forgery. I added data to this site, samsclass.info, and then when somebody viewed that page, it did an unexpected request to samsclass.info. There's nothing about a second site. It's not cross-site. It's on-site request forgery. So to make this work, you need a stored cross-site scripting vulnerability, and this is what the Sammy worm did on MySpace. He put something on his MySpace page, so everybody that viewed his MySpace page would perform unauthorized actions, namely making him their friend and adding a copy of the code to their page, so everybody that viewed their page would also make him their friend, and so he became the most popular person on MySpace quickly as this worm spread through the system. So you add this to the page, All right. So you can add this new user.php right there. You control part of the image tag. So now a viewer viewing the message will send a request attempting to create a new user. And of course, most users are not authorized to create a new user, but when an administrator views your page, they will be. And that's a pretty common trick. You've seen that in the Web Security Academy, and that's also what happened to the Apache project. You put up one of these stored extra actions on site request forgery, and you just wait for an administrator to view that page. This is part of why Microsoft always tells people not to log in to workstations as domain administrator. You should always just do individual actions with right-click, run as domain administrator credentials, because then you're not logged into that workstation persistently with those credentials, and this sort of attack won't work. It also means you don't leave a cached copy of your hashed administrator credentials on the workstations to steal, and it also means that if some kind of attack like this had happened, which involved tricking your computer into making an extra request, it would not have your credentials as administrator to execute that other request. So if you want to prevent this, of course, don't let users put arbitrary input in, which is pretty much the heart of almost every attack we're doing here. Instead of letting them put in something, which then feeds in the name of the field, just make them choose from several choices. If you have to accept other values, filter out all these characters. All right. So cross-site request forgery is just the same thing, except I put in a request that goes to a different website. Now, one website can make a request to another website. That is permitted by your browser. You could have a link if you're on City College that does something to Yahoo, and you might go to the Yahoo page, or you might even just send a request to the Yahoo page. You can do that, and it will include cookies appropriate to Yahoo requests, but you cannot see the response to that request, because that would leak Yahoo stuff back to City College. So that's the game here. The same origin policy does not prevent your browser sitting on one domain from sending a request to a different domain, but it does prohibit you from processing responses from the other domains. It's one way. So you can perform an action, but it's like blind injection. You'll perform it, but you won't see the response. And if somehow you have to load one page and then take the data from that page and go to the next page and go through multiple pages, you can't do that with this attack. You can only make one request, but that's enough frequently to do powerful things. So you can make a new account with this request, go to new user, step 2, and in here you feed the name, username, user role, password, and so on. So if there's a single request, that is all the administrator has to do is this one post request to make a new account, then you can input script on somebody's page that injects that, and that'll work. So here's when you have a vulnerable site. There's a request that performs a privilege action, and the only authentication it needs is cookies, which the browser will automatically add. It'll only work if you do not have an Anti-Csrf token, which we've talked about, which you should have, which would be a hidden field that's random on every page to make sure that any request to do the high privilege action actually comes from the page your server created, which it would only serve up to the properly authorized user. That's the trick here. So here's an example Csrf attack. You could inject this, which fills in the form to go to the target domain, and then it automatically submits itself here, document form 0 submit. So after it fills in this form with all these values, and they're all hidden, then it automatically submits the form. So just rendering this HTML is enough to make that form request. And if there had been an Anti-Csrf token, I wouldn't be able to do it because I wouldn't know what value to put in. But if it just relies on the browser cookie, it will work if it's viewed on a machine where someone has already logged in as administrator. All right, this happened to eBay. eBay was that you could make third-party website requests to eBay that would make a bid on an item. So all people had to do was put an image on somewhere else, like an image board, like Facebook or something, and viewing the item would make a bid on it. Is form 0 one of the fields? No, I think this is just a way to refer to the first form on the page. I'm not entirely sure. The way I usually do this is by referring to the name of the page. But you'd have to look up the, this is document object model notation. Yeah, I think they're stored in a list. I think this is a way to refer to the first form on a page. That would be my guess. But I'm not entirely sure. How secure is Facebook Marketplace to use? I don't know anything special about it. I would imagine that it does not have these kind of vulnerabilities that make it easy for people to cheat. But if it does have those, you can make money off them. Facebook has a good bug bounty program. Yeah, the labs use Form 0, yeah. So, well, this Form 0 question, let's pause a minute. We're not like we're in a hurry or anything. Let's take a look. This is the document object model, and let's find out what Forms 0 is and see what we do not need to guess. What does Forms 0 submit do? Form 0 will trigger the submission of the first form on your page. Okay, just what I thought it does. So Form 0 will be the first form. Otherwise, your form would have to have a name, and you refer to it by name or something. But this seems like a pretty good way. Form 0.submit. Okay, good. So it is just what I thought it was. But I'm glad you asked, and I'd have to look it up because I haven't done it that way. I did see the WSA Labs doing it that way, and I didn't like it. I did it another way. All right, so that's the game. And, you know, so I would imagine, like you said, that Facebook shopping site probably has Anti-Csrf tokens. I would think anybody fairly important and professional like Facebook or Amazon would these days. And if they don't, you can check it with Burp and you can make a pile of money by by reporting it to Facebook. People make a lot of money with serious Facebook vulnerabilities. If there's a way to buy products at the wrong price or anything, they'll pay you a good bug bounty for that. I'm confused about use cases for Osrf. Well, the on-site request forgery is where you're trying to exploit the same page that you're adding data. So, for example, I could put, if Facebook had cross-site scripting, and I could put script on a post, I could have you do extra actions on Facebook. For example, bidding on this Facebook website. So that's the point. It's when you have the ability to add script to a page, and you want to exploit that same server. That's on-site request forgery. Which, by the way, is probably the most common situation for a pen test. You're pen testing a company, and you're not supposed to be involving any other domain in it. So you want to, say, elevate yourself to administrator on that site. So you're putting code on that site to steal information from that page. That's the sort of situation where you do on-site request forgery. Okay. All right. So let's see. All right. So here's another one, for example, a cross-site request forgery, and this is a pretty big one in these days with the Internet of Things devices. People typically have smart devices in their home, like an internet gateway and a monitoring baby camera and all that stuff. All that stuff is just running on a local address, and most of it, if you send a request from a local machine, it will just accept that as authentication. You do not need a password. So I can use cross-site request forgery to add code to a page which will then do something like turn off your firewall or turn on your webcam or something, or open your garage door, change your heating, that sort of thing. Because you view it on a page and then your browser sends a request to your home devices, which probably have an easily predictable URL and probably either no authentication at all or a default name and password. So this is a fundamental weakness with the local area network model, and that's because most people's homes are still having the old security model that Microsoft recommended until 2002, where they have a barrier on the outside, like a firewall, and anything that's in the building, they trust it. They think there's a trusted boundary, and anything inside the building should be trusted. If they move to the zero trust model, then they wouldn't trust requests even from the local networks. They would verify them. All right, so if you want to prevent these, then you don't accept cookies as enough evidence that somebody has logged in. You also have to have a hidden Anti-Csrf field, which proves that not only do they have the right cookie, but they actually came from the expected source. That blocks the CSRF attack because the attacker has no way to find the anti-CSRF token. So the token has to be random. It has to be different for every user, different for every session. All right. Now, you probably know this. Visited links change color in your browser. Here's some links that have been visited, and this one hasn't been visited, something like that. This is a standard feature of a browser, and you can interrogate that. They can't find the token by searching the DOM. Well, they might be able to, and we did that in a previous demonstration. We injected a script which would then make a request from this page and find the token. So that required us to work from the restricted situation where we inject the script right on the page that has the token. So you can search the DOM and put it on, but if you think about it, the most powerful attack is cross-site request forgery, where I could put something on Facebook and buy something on eBay. And in that case, there's no way the Facebook page would have the eBay anti-Csrf token. Now, if I'm doing on-site request forgery, and I'm, say, on eBay, and I want to make a buy request on eBay, if I can inject code in the description of a product, then the problem is that's not the buy page. So my script is not running on the page that has the anti-Csrf token. That's why that lab that we did last week or the week before, where we had the script that actually stole the CSRF data from the page, that was a very specialized attack that only works under a particular situation when you can inject the script right on the page that has the CSRF on it. In that case, you can. But that is a rare case. These are very good questions. All right. So anyway, so here's a trick to find it. Now notice that things change color when you've been there. So that means if I had a query string with the CSRF token in it, then I could just try going to different URLs, generating guesses, and I could use the JavaScript API getComputerStyle to see if that link has been visited. So I could try thousands and thousands of tokens locally in the browser without sending any data out at all. The JavaScript will just create the URL and then call this getComputerStyle to see what style will be used to render that URL and decide whether that URL has been visited. So I could pump out a supposedly random number this way with a local attack inside the browser. Now, I'm not sure if this will still work, because there was some stuff published about 5-6 years ago of people using this to fingerprint browsers, and I heard some talk that browsers were being modified to restrict some of these methods. So I'm not sure this would work in a modern browser or not. But there's certainly a time when it did work, and that probably means it'll still work in some browsers. All right, so an anti-Csrf token will prevent something like this, where I try to run a PHP with like a buy page, where I try to inject a buy request here, because it will send an Amazon cookie, but it won't know the value of the hidden anti-Csrf token. If you want to defeat those defenses, that's the one we were just talking about. If I have stored cross-site scripting that enable me to add JavaScript that will read the token, it'll work, but I'd have to be able to inject script onto the page that includes the CSRF token, or if they don't really use the anti-Csrf for every page, or if the token is tied to the user but not to the session, I might be able to use a token from a different page on this page. So, if you do not correctly implement your anti-Csrf, which means randomize it on every page, then I might be able to beat it. All right. Let's take a look at a Kahoot. Here. (13A1). There we go. All right, maybe we got everybody. Okay. Okay, so how do you prevent CSRF attacks? All right, you have a hidden field. That's what the Anti-Csrf token is, a random hidden field. All right. All right, so which attack requires stored cross-site scripting? Well, in the slides it says on-site request forgery requires it. I'm not so sure it requires it any more than cross-site request forgery, but that is the answer I expected from the book. I'm thinking I don't like this question all that much, but anyway, that's part of why they're extra credit. They're not always perfect. Osrf is the expected answer, but I'm not sure CSRF might be just as intelligent an answer. All right. So what method of authentication causes these vulnerabilities? The cookie, now if the cookie is basically a single sign-on message, you sign on once, and then you visit many pages, and it automatically sends proof that you've already logged in. And the same kind of vulnerabilities appear in a more abstract level in Microsoft in the pass-the-hash attacks. You sign into a Microsoft domain, and then you send a hashed version of your password up to prove that you deserve to be in there. And it keeps on sending that same thing. Well, it's a Kerberos ticket, so it's related to your password, but kind of indirectly. And you keep sending that with every request from then on to prove that you're allowed to be on there. And just like a cookie, an attacker can steal it and impersonate you, or they can trick you into making unexpected requests from your machine, and they will be authorized. So it's very similar. Anyway, that's the cookie. And what was the Sammy worm? It was on-site request forgery. He put a script on MySpace that ran when other people went to MySpace. There was no cross-site. It was on-site request forgery. All right. All right. All right, good. I've got the winners. Okay, so the next one is pretty fun, and it has just come back in a new form, UI Redress. is where I trick what you see into being different than what the page is really there. If I could make a transparent page and put it on top of another page, you could click on something without seeing what you're really clicking on. That's the game. So you have a page here that has a win button, and there's an invisible page on top of it where you're confirming a funds transfer. That's the idea. This is in fact easy enough to do with cross-site scripting. And I made a simple demo here. So let me shrink this down a bit, make it fit. All right, so here's what's going on here. I guess I can make it bigger again. All right. So there's a good button and a bad button, and here they're next to each other. So you click this one, you win an iPad. You click this one, you get hosed. And now all I do is I put them on top of each other. Here's the harder choice. Here I put the second iframe on top of the first one, and I've changed it to 10% opacity. So there's win an iPad, and on top of it is this page at only 10% opacity. So you can see a little bit of the green page. So when I click on this, I'm really getting hosed. I'm not getting the iPad. And of course, since that was 10% opacity, I can take it all the way to 0% opacity to where the, voting machines are a fine example. Yep. So now there's a totally invisible hosed page there. So when I click on win, I get hosed. And there's no way you can tell from looking at this. So that's pretty scary. And this is called UI redress, where I present the user with a confusing page and get them to click on it. And by the way, it's not that different than what the Republicans and Trump have been doing, and before them the Democrats did it, where they would ask you to donate, and then they would have confusing stuff on the page. So the default was you'll keep donating again this amount every week or every month. So, you just confuse people into having an unexpected result. But this is where they make it look really different. And one just came out last month, a new version of this, the browser in the browser attack. And let me just show you this one live because it's fun. This is just another version of the same thing. Well, I've already got it here. So here's the page. The point is, when you go to a website like Kahoot, you can log in with like Google. And if you do, another page will pop up like this saying log in with Google. Everybody's used to this. Log in with Facebook, log in with Yahoo, log in with Google. This other page pops up for you to log in. So all you have to do is make a duplicate of that page and pop it up. So here's the phishing page and here's the real page, and you can't tell the difference. This is actually really deadly because you can just totally copy this page. You can copy the CSS and the HTML, so you have an absolute picture-perfect image of it here. It is a real problem. And anyway, he's got a demo here, which is kind of fun. Sign in with Microsoft. It pops up. There it is. The only thing it will tell you is that you can't move it out of the frame of the page inside it. So if you go down, I thought there was a better, all right, I guess I'm not seeing the better video. The point of it is the pop-up page is inside the other page. Yeah, you move it around. You won't be able to move the window completely outside the other window. It's actually inside the window. That's your only clue. But that's not obvious. Yeah, perhaps even the URL. The URL would have to be different. Here's how you make a custom URL. But the problem is many people, test it by dragging out of the browser window. That's right. The dragging out of the browser window would be a good test. The URL will be different, but if you're using a mobile device, it won't show you the URL. And there are tricks to obscure the URL he describes down here too. So anyway, people are getting very excited by this. Why does that not work for the attacker version? Oh, because the attacker version is actually just an iframe within this frame. So the attacker version here is an iframe within the bigger frame and cannot move outside the window. The real third-party authentication is a separate box popping up. And he doesn't show you the script here, which I would like to see. But he is, in fact, doing it with iframes. I think iframes are restricted like that. I don't think you can open an iframe in a separate box. Although I never have tried. I'm not really sure. Anyway, and I don't think I see the actual page here. So I'm going to it'd be fun to actually do this. So let me put this here. You folks might want to go here if you're interested. It would be nice to actually find the code for this and set it up and learn more about its limitations. But it's getting a lot of attention right now. Anyway, that's the modern version of a UI redress attack. This old idea keeps coming back. And the fundamental problem is what you see is not necessarily true in your browser. All right, so you could steal keystrokes from one window and implement them in another window. So while you think you're typing a letter to complain about something, I could be stealing those key presses and filling in like a request to buy my product or something. I can grab certain characters and pass them to the other interface. I can steal mouse movements, like when you're dragging something. I can trick you into, you actually are dragging and copying text when you think you're like dragging a game piece around, that sort of thing. So one way to protect against this is to bust out of frames. Each page of an app can run a script to see if it's loading in an iframe, and it tries to bust out of the frame. Here's an example. Here's a frame busting defense. If top location is not equal to self location, then move to the top location. So this should take any script that's running inside an iframe and move it into the top. So it's not running in that limited environment. This is a way to bust out of some unexpected frame you're in to the host. So it sounds pretty good, but Stanford found that they could defeat all the frame busting defenses that were in use. This one here tries to move up to the top, but the problem is the attacker controls the top frame. So they can redefine a variable called location. And then when the script refers to top location, it will not be the document object model referring to the location of the top frame. It will just be this text variable foo. So when they try to use it to move there, it'll just be an error. The JavaScript will not take effect. So the attacker can hook this before unload event. So the attacker's event handler runs and redirects it somewhere. So they can trick the request to move to that frame into an invalid request that will be canceled. You can define a sandbox attribute, and this disables all scripting in the child frame while leaving its cookies enabled. So now the frame busting script will not run, but the attack will still work because the cookies are still there. And there's another one that's really nasty. There's a cross-site scripting filter in Internet Explorer. And so I can put suspicious looking stuff in the iframe so that when the browser runs script inside that frame, it will look suspicious and the cross-site scripting feature will block it. So it turns out that trying to use JavaScript to protect yourself from this iframe attack is very weak as a defense. So the correct defense is to add a header to the page. Xframe options, that's why they have this. You can set Xframe options to deny for your login page, and then your login page is not allowed to load in a frame at all. This is much more like it. That tells the browser, never load this page in a frame. And therefore, any attempt to put it in some frame and hide it behind something or in front of something will never work. So that's a much stronger defense. All right, and remember, mobile defense, web pages often lack these redress defenses, which is not good because you can do these attacks on mobile devices and people can use mobile pages in normal browsers. And sessions are often shared between both of them. All right, normally I cannot prevent code running on one domain to access content delivered from another domain. That would violate the same origin policy, but there are tricks. One way to do it is inject formatting HTML. So here I have some ability to inject code up here, and then there's a form down here that's going to send something to this wamail.com forwarding an email. And in here there is a value. This is the hidden Anti-Csr token I want to steal. I want to steal this number here. What do I mean loading in another frame? Well, let's go to the demo here. There. So here, remember there are two frames. You think you're clicking on this, but you're really clicking on that. And so in order to do that, I had to take this content and I had to load it in a frame and make it transparent. So that content was loaded in a frame. If I had put that header field in the defense field here, there, X frame options to deny, then I would not be able to load this in a page. And see, remember the thing is, I'm trying to trick you into running something on somebody else's domain. You think you're playing a game or something, and I'm trying to trick you into doing something like clicking a buy button on Amazon. And so this is really somebody else's domain. That's what's valuable. So if Amazon had put that X-frame options header on their page, I would not be able to put their page in a frame with invisible opacity. So you think you actually click on an Amazon buy button when it's something else is what you see. That's the point. So that's why putting it in a frame is necessary. The whole point is I put up something you want to click on, and I put something invisible you don't want to click on top of it. And if the invisible people had used the X-frame options header, I wouldn't be able to do it. Sessions are shared, yes. Means this, exactly, that's exactly what it means. It's the same session on the iPhone versus the laptop, and that is very common. They're the same cookie. And if you steal the cookie from the phone, you can use it on the desktop. Are the options in the header only allow or deny? No, there are more choices. You can have deny or same origin, and I think there might be other choices too. Let's just take a look. These things are pretty well thought through. Let's go here and look at these values. Let's see what else there is. Yeah, here's the Microsoft documents. So there are, I guess the only ones they say are deny and same origin. That's all there is. Okay. I thought there might be others, but I guess that's it. No frames at all, or only frames from the same origin. That's it. But anyway, that was put there just to stop this attack, and it is considered quite effective. All right, so here is another case where suppose I have the ability to inject some HTML before a form, and I want to trick this form somehow into letting me steal that value. Here's one way to do it. I can put an image source tag with the URL I want to steal it with an opening apostrophe, but without the closing apostrophe. Now, it will take all this data up to the first apostrophe and interpret it as just a parameter here. So it will now send all that data to my server. That's the problem with this parsing, where I take the first quote and I look for another quote. Now all this green stuff is not going to be taken as HTML tags having an effect. It's all just going to be the value of this HTML parameter sent to my server. So that's pretty awesome. If I can inject an image tag, or this one's even nastier, I can inject a second form tag. And I was not aware of this, but if I have a form tag and then another form tag, it just ignores the second one. And now it'll send all this data to my server instead of your server, which is pretty handy. So those are kind of fun ones. All right, you can also do it by injecting cross-site cascading style sheets. So you can put text. So suppose I can put in text in the subject line of an email. I can put in this stuff, where it defines a cross-site scripting parameter defining the font family, and again, just an opening token. Now it's going to take the content of the data below it. And so here I was able to inject this font family. Now all this stuff up to the first quote again is going to be interpreted as the CSS font family property. So it's going to try to load a font, which ought to be something like Arial or Courier, with this long name. And now I can host a page on my own domain and include the injected response as a CSS style sheet, and I can then query it with JavaScript to get the name of the font family. And it will show me the name of the font family, which will include that page, including the Anti-Csrf token. How would that appear to the user? Well, if you loaded a page like this, you would not see this stuff up to here. So it would break it. The page would render badly. So you would load the page. It would load kind of badly. Parts of it would be missing. And what you don't know is those parts have actually been stolen to an attacker. So you would say, oh, something's wrong. And I guess you'd probably like close your browser or go somewhere else. And in the meantime, I've got your token and I've logged in as you. Good. All right. And so you can also take JavaScript from somebody else's domain. Remember, you can load JavaScript from another domain. It happens all the time. If you look in the header of a page, it's often loading JavaScript from standard libraries, like the JavaScript template engines. And normally, that's because all you're loading is like standard open source code that doesn't include anything sensitive. But the problem is modern Ajax sites do use JavaScript to handle sensitive code. So here's an example. User logs in and clicks Show My Profile. Now, if it was an old-fashioned page, it would show you a static profile page. But if it's a modern page, it will dynamically load this script, your details, in JSON ASHX, Microsoft scripting, and that will get your user data and make this function call, show user info with all this sensitive data in it. I can now trick that. I can make a page that loads the same script but defines a different show user info. So that when instead of taking show user info of X, I does alert X. And now if a logged in viewer views the page, their personal details will pop up. And of course, I could change this alert to send it somewhere else. So yeah, I trick them into going to my page. Then this is the Csrf attack. It now requests your details from some other site, and this function causes it to send it to my place. That's the idea. Because scripts are allowed to load from other sources. And the same origin policy did not consider that a script might include sensitive data. All right, so if you want to prevent this, you could use Anti-Csr Tokens. Here's a kind of a cute one. You could poison your JavaScript with an infinite loop at the start, so nobody that directly loads your JavaScript will ever be able to run any of the methods. And then you load it with an XML HTTP request and strip out the bad code. And that apparently is only possible from the same domain, so that's one way to make it so if anybody else loads your JavaScript, it won't run. Right, you can also make it so your code can only be loaded via post requests. And again, that can only be done from the same page. How would that be used? You use it, you make it so you cannot load the page with just a script source tag. You have to load it with a special XML HTTP request and then ignore some of it. So I don't have an example of this, and it's a little confusing. But if the XML HTTP request lets you load something and then manipulate it, where just a script source will just refer to that script and run the methods in it. Yeah, it'd be nice to see an example of this, and I'm afraid I don't have one just to look at. All right. And HTML5, yeah, a use case would be better. I don't have one, unfortunately. I don't think there's one in the book either. Anyway, HTML5 modifies this request to allow two-way domains if you give it permissions. So if you do this, HTML5, your browser adds an origin to cross-domain requests. So you know where you're loading the script from. This is so you can define some degree of trusting another domain. And so the server response will include headers that tell the browser what to do. This is the modern solution, and I have hit this a few times. Remember, I thought this was the problem with a bug last week or the week before. When you try to mix data across domains, you can do it these days, but only if it's permitted. Your browser tells, when it makes a cross-origin request, it tells the server what domain is requesting it, and the server has rules about what origins are allowed. So you can define, like if Yahoo buys AOL, your Yahoo servers can say trust script from AOL, but not from anybody else, that sort of thing. So we do have some degree of controlling the script trusting these days in HTML5. All right. Well, let's take a look at the last Kahoot, which is back here, right here. The headers can be modified, but only by the server if you're using HTTPS. If you were using HTTP, then a man in the middle could modify them. But if you're using HTTPS, then only the server administrator could modify them. Unless you're able to inject headers, which sometimes you are. Yeah, if you could get in the middle like Bert, then you could modify them. I think you're right. This is one of the many reasons why these days all HTTP is considered unsafe. Everything should be HTTPS all the time. You know, related to that, another thing I wonder is what if you're using an old browser that doesn't honor those headers? That would seem to be another issue. But of course, then you can only attack users that happen to use that really old browser. All right, looks like we got everybody that's coming. Okay, a weak defense against clickjacking. Yeah, frame busting, where I try to add script to the page to tell if I'm in a frame, that turns out to be pretty easy to defeat. That was the first attempt to protect against this. All right, so how do I steal a token with HTML injection? Yep, if I can add a form tag, I can cause the existing form tag to send the data to a different server. What's the best way to stop clickjacking? the X-frame options header is the new strong defense. All right. A header field the browser adds to XML HTTP requests. Yep, it tells the server what origin you're from so it can decide whether that origin is trusted. All right, so which one is also called clickjacking? All right, UI redress is also called clickjacking. You click on things, but your clicks are actually taking effect on something different than what you thought they were. All right, a two-time winner. And another two-time winner. And DDD, I know who that is. All right.